That seems better. Okie dokie, let us share this on Twitter. Why I keep doing this? I don't know, but I'm gonna do it anyway. My track 0 channel has... Oh, we need to rename this. This is... God, episode 6 already. I'm blasting through these. KK. Updated. Copy this link. Okay, tweeted. You've gotten through the boring intro part of this video. So, if you are just joining me, we are... Here, let us go to Facecam. If you are just joining me, we are working on turning an NES into a functional 8-bit PC type thing. Evening. So far, we have gotten a hacked Super Mario Bros. 3 cartridge with our own EEPROM in it that is running custom code. But we still have the character ROM from Super Mario Bros. 3, so for characters, that's what we have to work with. Yeah, and last time, I got some code actually running on this, kind of. So the goal here is to make it run Microsoft Basic at some point. But the big deal is we need to make some input in the form of a keyboard. We need to make some output in the form of putting characters on the screen. We're working mostly on that part right now and trying to pull the text characters that exist in the character set of Super Mario Bros. 3, try and get that mapped correctly into the Nintendo's video hardware, and then display them on the screen. Last time we kind of figured out where those characters are, how to get it mapped using an emulator, but oh yeah, we had a power outage just as I was about to put it on the cartridge and test it on real hardware the other day, and so far we have gotten A, as Vram points out. Yes, but we can't even read it. Actually, I could do this right now because the code is on the cart. Hey, I did set up a hotkey for this. Very nice. So hopefully if I turn this on, that's the reset button. That's what you get. Not quite as good as the code was on the emulator, but after the power outage, I did post on my Discord, which has a handful of people on it now. And I'll just keep dropping the join link in chat for anybody who wants to join, because I know random people are watching at various different times. But anyway, if you were on the Discord, I'm kind of leaving my rambly notes there. I think that's going to be the point of the Discord, is for me to leave rambly rants and people to read them so they can keep up, you know, when the power's out, for example. But the power went out, and then I managed to actually run it on the hardware, which I didn't show because the power was out last time. So we get this. So as I was suspecting at the end of the last video, I'm pointing with my mouse like you can see it, but you cannot see it. But, you know, you can see some various, you know, you can see some A's in there, you can see an O over there, you can see an E. So the MMC3 mapping stuff is working correctly, and that's the part where basically this character ROM has much more capacity in it than the Nintendo can actually address, and so there is hardware to kind of swap in chunks as the game runs, to swap them in and out. And so I had to get that working properly so that the part of the character set that has the letters in it is available to the video card. So that worked, and we have garbage on screen right now, but upper left-hand corner here should be an A that I actually set through code. But we can't see it because the palette sucks. So we are back to doing some research, because I vaguely know that there is... Okay, the main thing that I really don't know is how NES palettes work. I think there are like a handful of fixed palettes. I don't think you can specify colors. I don't know, we'll find out. And then there is kind of like, I believe the ZX Spectrum works, and some other hardware. There is what's called an attribute table, which actually assigns palettes and various different other attributes to chunks of the map that's on screen. And that's why various different parts of that screen were, some of them were gray on gray, some of them were black on gray, some of them are white on gray, because each cell has like a different palette setting and stuff like that. So clearly I don't know all the details on that, but I know that's a thing. So that's two things we have to do, is set the whole attribute area to like one uniform thing, because I just want black on white, or white on black text, and make sure the palettes, however the palettes are set, are the same thing. It might all just be the attribute table. I don't know. Let's go along for this journey. So, as is our tradition, let us go to NES Dev, and let's look up. I guess we could start anywhere, and I'll just work backwards. Oh, so I know they have a page on PPU memory map, and that should tell us where... Right, so it starts with the two pattern tables, which are the areas in memory that are basically coming off the character ROM, where our actual available tiles that we have to work with are. That is followed by these name tables 0 and 1, which are the kind of the screens, so that says how the tiles should be laid out on screen. There are actually 4 name tables, but depending on, there's only enough VRAM to physically have 2 in memory, and they get mirrored various different ways, but I don't care because I won't really be doing much scrolling. Then there are some mirrors of that. Okay. Then we have the palette RAM indexes. So I'm going to go ahead and click that palette RAM link. And what is occurring to me now is I actually believe, let's open the page on name tables, because I was sort of looking at these last time to figure out what we were doing to get the characters on the screen. And what I want to know is, I believe the name tables actually have the, yes, attribute table at the end. So a name table is a 1024-byte area of memory used by the PPU to lay out backgrounds. Each byte in the name table controls one 8x8 pixel character cell, and each name table has 30 rows of 32 tiles each for 960, or hex 3CO, bytes, which is not a full 1024, because 1024 in hex is 400. So the rest is used by each name table's attribute table, which is the thing that I was just talking about. So let's look at the attribute table. So like I was saying, it's broken up in a grid of cells that I believe are bigger than the cells, than like the actual character cells. So you can kind of set regions. Yeah, this is a good illustration. You can set regions of, you know, you can set like mirroring. You can set, probably the palette is set there. We'll read about it. and stuff like that. So, like you can see, this guy right here is 2 sets of mirrored characters, because mirroring is almost assuredly an attribute here. Yeah, so let's just read. The attribute table is a 64-byte array at the end of each name table that controls which palette is assigned to each part of the background. Each attribute table, starting at 23CO, 27CO, 2BCO, or 2FCO for each of the name tables, is arranged as an 8x8 array. So, there you go. Now, what do each of those bytes actually mean? Color bits 3 through 2 for top left quadrant of this byte. Okay. Let's read some more, because that doesn't mean anything to me. Each byte controls the palette of a 32 by 32 pixel or 4 by 4 tile part of the name table, and is divided into 4 2-bit areas. Each area covers 16 by 16 pixels or 2 by 2 tiles, the size of a question mark block in Super Mario Bros. Given palette numbers top left, top right, bottom left, bottom right, each in the range of 0 to 3, because you can have up to 4 colors on the NES, the value of the byte is... Oh, okay, so they're saying, yes, I could have read that, or equivalently. So, I see. So I will just be setting these all the same, because I just need... I mean, it's going to be the same palette on the whole screen, and all of that. I am interested, though. Not that I'm going to use it, but, like, clearly mirroring is a thing. Is that not set via the attribute table? I don't know. Let's ignore that for right now. Well, nah, I can't just ignore it, because if we look at... There we go. If we look at the screen again, like, there's obviously flipped tiles and stuff. Upside down A is not a character in the character set, so there's clearly some attribute that's setting that to be mirrored vertically. Well, let's burn that bridge when we come to it. Yeah, let's burn that bridge when we come to it. For starters, you know what we can do is just make a nice little tight loop that... So color bits 3 through 2, that's the part I'm not getting. I don't know, I think that's just written poorly. Let's look at palette stuff, because I'd imagine what this is actually saying is it's specifying one of 4 of the PPU palettes. Yeah, because, I mean, even looking right here, there are 4 background palettes. So I imagine each one of those possible 4 values that each of those 2-bit fields in the attribute byte can be specifies a palette to use for that tile. Gotta be, right? So let's see what a palette actually consists of, because I'm going to imagine the steps I'm going to need to do just to get the palette stuff right, we'll get to the mirroring and flipping stuff later, is set background palette 0 to however this gets set, and then just fill the attribute table of name table 1 to all zeros in a nice little 64-byte loop, and that should just set it to palette 0, and we should be happy. I think it's that relatively easy. You know what is fun, though? What is super fun? Let me see if I can open my old tabs, because since I have been using... the Windows Reconnect sound isn't working. I didn't even notice a disconnect on my end, so whoops if you missed some stuff. Yeah, theoretically desktop audio is actually off this time. Let me know if that's not correct. You shouldn't be able to hear that sound. Anyway, yeah, let me see if I can reopen and if the state is still there for the online assembler that I was using, because I have to stop using that for this exact reason. Because this is not tenable. I lose my code every time my machine goes down. Virtual 6502 assembler. All right, fingers crossed. Oh yeah, no, I didn't remember a damn thing. Thankfully, let's see. I still have the actual ROM on my machine. And one of the nice things that Masswork has is they also have a disassembler. So I should just be able to use that to reconstitute my code. Let's see. It's just a PC. NES. Oh, I am not showing my desktop. Here we go. Oh God. And I was doing a bunch of explaining while you were not looking at my screen. Whoops. Let me go back really quick so I can give you the visuals that you were missing. Yes, so palettes. This is what I was talking about. I was looking at the page on palettes, so it looks like we write palette values, whatever those are, at this address, and then the attribute tables is this thing. I don't know if that got shared or not, but basically the attribute is at the end of the name table and is laid out like such. So 4 quadrants of it can each be assigned to one of the 4 palettes. Anyway, let's get this thing disassembled. Choose file. It's just a PC, NES. And we were looking at showna.bin. Let's see how clean this is. Okay, it actually disassembled all the zeros. That's fun. Oh. No, my ROM should be 64 bytes. Where's the code at E1000? What on earth? Huh? It's another random one. Okay, so this was one of my random... Let's disassemble this. I don't think this was the code that I last wrote. I mean, worst comes to worst, I can pull the EEPROM out and read it and get the code that way. This looks better. I'm hoping that this was my test code that I had removed around to put onto the cartridge. Hopefully. Let's review what it's doing. So it put a 0 in A, and then stored it in 2000. Yeah, I don't trust this. Let's just pull off whatever's on the cartridge and disassemble from there. Touring this off. Probably not, but let's see if it's still loaded into XG Pro if I bring it up. Nope. Nothing so easy. So, I will just yank this guy out, and we will read it, and we will reconstitute from what's on the chip. This is real archival file storage, you guys. You put raw bytes on your chip, and then you stick it into your EEPROM reader later to get your data back. I have legitimately thought about storing like a master password this way. Then you just throw the EEPROM in a drawer. Nobody knows that's where you're keeping it. But you know. Seems more like a gimmick than actually useful, so I haven't done it. Okay, pop that guy in there. Nope, that's the wrong direction. Where's my desktop? There's my desktop. Okie dokie. So we will read. No, I don't want to verify. Yes. Do you think it'll care about the check ID? Exactly like in a spy movie. Yes. Okay, we're reading this. It is read. And now I have to get this out of here. And we already learned that this won't just be a string, so let's save this. Ooh, block save as. That might be useful. So let's go from, what's my halfway point? It's 1,000, right? Should be. Yes, because FFFFF is going to be the end of the first 64K. So if I just block select from here to the end, oh lord, which is going to take forever. Wow, this sucks. And that didn't select anything. Neat. Okay. I know a hack we can do. We'll just save the whole friggin' thing. Sure. I don't really care. Alright. Then we load. Oh, damn it. I was hoping it would default to the same folder. Whoops. I have no idea where that was. Let's save it to some place that I actually know. For a second, I was terrified that I had to manually put in the path. Thank God I don't have to. Right. Documents. Is this PC? NES. Save it as starting content 84.bin. And we will save it and then load it, but you can load with an offset. So I will load from that same file so that we can shift everything back down, and then I can open it somewhere else more useful. Starting content 84. And from file start address, 1000. Sweet. And now I should be able to resave this off as, let's just kind of verify. My code should start at E1000. Boy, I should really find that go to address function in here. I could just load it in XVI32 if I was smart. We'll get there. Come on. We're at D. E. And then, of course, you overshoot it. Yes, there is code at E1000. Perfect. So now I have this, a copy that is shifted back down. So let's save this again. Let's save it over exactly this. Hi. Now I can just load this file directly, and it's relatively heavy. Apparently not. Why did it end at 1FF8? The hell? What? Oh, did it wrapped. That's funny. It wrapped and then just like stopped. Okay. But hi again. Okay, there's our code at E1000. So let's just ignore all that other stuff. And let's see if I can just load from E1000. I'm just going to go to E100 because I know what's at the end. It is just my reset vectors. Okay, you still gave me... Wait, the hell? That's not all zeros, you know it. Oh. Wait. Am I back? Okay. Yeah, this isn't working the way that I would have thought. Okay, let's just disassemble the whole frickin' thing. Whatever. And then I'm just going to have to scroll. Boy, this is not very good, I don't think. It's only willing to write so many break instructions and then it just dies. Come on, man. Okay, let's go one more time. Let's load this from... let's just truncate this. So we're gonna reload the same thing, but we're gonna start at E1000. Yes. Okay. This is more reasonable now. I would love to just copy this as text, but I can't do it! Oh, I wonder if I can, like, export this as Intel hex. 1 second. Then I could just copy-paste. After doing all of this work. Yeah. Intel hex. That's too late. 8.4 truncated. Okay, let's try again. I feel like it's still not going to like how big this file is, but thankfully I can probably truncate it pretty quickly in XVI32. Boo! Boop-a-doo-ba-doo. Yeah, it kind of did the same thing, but now that is actually at the top, so let's try. Yeah, because see, it for some reason it only lets me disassemble the 3FFF. Don't know why. Probably because my file is too big and it makes it go crazy. That looks more... Okay, while you were not looking, I have copied this code, and I am going to drop it into Visual Studio Code because we're actually going to start saving our work. I know that's a little insane, but I think it's time to start. And we're reconnected again. Yeah, it's one of those days. And I'm not even going to try having it detect an assembly language because I don't know what assembler I'm going to be using, honestly, because I'm going to try and steal the existing Microsoft Basic code eventually, and that is for some weird assembler that I'd like to just use the actual assembler they used, but I don't know if one can actually find that. So anyway, let's see if I can use some quick regexes to just delete everything. Is it \D for digits? Yes. And then 4? Nope. That's a character class. Shh. How do I specify a number of them? Well, you know what I'll just do? Hey, Steve. Oh boy. So you got the reconnect sound without it actually reconnecting, so maybe it's lying to all of us? I don't know. I don't really watch these back, so anyway. Yeah, you want to watch some regex stuff, Steve, done live with me not being able to remember? I guess let's just replace any... this is gonna be gross. You know what? F it. Let's, I don't want to use regex. I don't want to, I tell you. I think I can use block edit characters much more easily. Or commands. No! Apparently block edit commands are not supported in Visual Studio Code. I'm using a Vim extension, so... Damn it! What if I just do it the lazy way? The boring way. Because if you're in actual Vim, it has block select mode where you can select a rectangle of characters and then use a command to modify them, whether you want to just delete them or whatever. But no, I just have to backspace this like a moron. And this is why we've only gotten as far as we have. I don't even have my original code back yet. Good times. But soon. And it will be saved. Okay. Did it actually disconnect that time? Shift-Alt? Boy, is that like a normal Windows editing key combo that I am not aware of, because that would be good to know. Okay. So, got our source. It's cleaned back up. My whole frickin' work team is in chat, so that's no pressure. Yes, so we have recovered the code we were working on yesterday. Let me just indent everything for prettiness, put a label here. Let's call this, I don't know. Let's call this echo loop, because what is going on here is, and I don't know if it made it into the stream before my power went out last time, but this is some demo code that I wrote earlier to prove that things were working, that echoes, if I poke a wire to the data input of one controller, it shows up on the latch output for both controllers. So I figured I'd just include that if I was going to do a halt loop. So that's in here too. And it still does that while showing our nonsense screen. So we need to change this label back to echo loop. Maybe increase the font size just a little bit, because streaming. And let's get some comments back in here because we need them. Oh, and I have to redo my my offset calculation crap. So this will be fill. It should be the ooze. We're gonna. I think this was the syntax. Fill. I think it's what to fill with, and then how many. So E1000. Then this will be our entry point. And yes, now some comments. Turn off interrupts and decimal mode. And then I have to remember what this code does. Right. So it loads 00 into register 2000, which I should have made defines for these because I can't remember what any of these registers are. 2000 is one of the PPU like basic. Yeah, and you know what? Let's move, because this is also initializing the PPU itself, so let's move this up to here. And then, because I had only put those together because I could cleverly only load A with 0 once. Whatever, I don't care about how much space I'm using yet. Let's turn on background and sprites. And then this is set up the MMC3 to map the text characters to the first mappable block. And yes. So 2005 was that MMC address register. No, what is 2005? 2005 was also a PPU register, wasn't it? Let's look at PPU registers. Registers. 2005. Oh, right, that was the scroll setting. Right. So, right, this was setting the scroll to a negative scroll value, vertically. That's right. Okay. Then this was our MMC mapping stuff. So this is nope, I did not put that in my clipboard because I'm not smart. Anyway, set MMC3 to map text characters into the first bank. That does that. And then what is 2006 and 2007? Huh? I believe those were writing the A character. Yeah, I think 2006 is the PPU address register. Yes. So, right. So we're writing to 2000 hex is the address that we're writing to in PPU memory, and we are writing a 30 there, which is the tile number for the letter A. Yes. This is all coming together. And then I'm going to go ahead and put this in front of echo loop because we're only doing the clear carry for the branch of carry clear. All right, we're close. Discovered your channel via your incomplete computer build and saw your SGI machine video too. Hope you get a chance to do an M68K at some point. I dream of being able to build a PGA M68K Linux system. Yeah, someday. That's probably way off in the future now because I've given myself this task, but I am... Theoretically, my next project after the NES is going to be doing this same silliness to a Genesis, so it's a 68K, that's better. A dual 68K, like, when... Okay, so, Wereworm says, I have a dual M68K system from an old EMC storage. So when you say dual 68K, do you mean actual 68K, not like a later, like 68010 or 020? Because those things are crazy. Early Sun systems had dual 68Ks because 68Ks can't... if you try and put an MMU on them, and I'm going to remember this not quite right, they can't recover from a bus fault. They can't, like, cleanly roll back their state. So, you know, if you try and access unmapped memory and then you throw an exception so that you can map memory in there, it can't back up. So they would actually have two 68Ks on there on, I think, early Suns and I think like Apollo Domain workstations or something. And one 68K would actually hard reset the other 68K, if I remember, on page faults. It's crazy shit. Anyway, that's the rant on old computers for the day. Okay, so we put a label at the end of code so that we can calculate fill. I have to re-remember this again. I think it is code end minus F. So FFFA. Yes, because we need to fill. This is just like the last episode. We need to fill the number of bytes between FFFA and wherever code end is. So it's the other way around. It's doing, which is exactly what I did last time, which is doing them backwards and then turning them around, because math, and me no brain good. Maybe it is count and then what to fill with. Let's actually try that because that feels more right for that one. My fingers remember that more. Okay, so now we can finally write word 0000 for our one of our interrupts. It's not break, whatever the first one. Oh, IRQ. Word, and then this will be our actual entry point, because that's the entry point vector. I think we have... Okay, and with all of my vectors set, I think I have reconstituted my code. I hope, maybe. So let's save this frickin' thing. Let's save it in the same frickin' spot. Nope. It's just a PC. NES. And let me make a source folder. And let's call this 8.4 reconstitution.asm. And select everything and drop it into the assembler and see if I get something reasonable out. Assemble, fingers crossed. Assembly failed. Sick. What? So for this fill... Right, it uses square brackets. We learned this last time. If you're wondering why I'm having so much trouble with that, the keycaps on my keyboard don't actually match what some of the keys are. Because it's a Japanese ISO layout, and my machine is not set to Japanese ISO layout. Okay, so we've got that fixed, dropped in there. Assembly succeeded. Sweet. So again, our code should start at E1000. E1000. Yep, that looks promising. The main thing I wasn't sure about was those fill commands. And we have our vector here. So this looks reasonable. Yay, we finally have our code actually saved off. So now let's start working on it and do the stuff I was just saying. So the palette is in VRAM, and theoretically, if I write to 3F01, 3F03, that will set my palette 0 values. But what does the actual color values look like? Let's see. Each palette has 3 colors. Each 16 by 16 pixel in the area can use a backdrop color and 3 colors from one of the 4 background palettes. The choice of palette for each 16 by 16 pixel area is controlled by the attribute table, which we were looking at. Each sprite can use the 3 colors from one of the 3 sprites. I don't care about sprites. Addresses 3F04, 3F08. Are those ones we care about? No. So I don't care about those. Addresses, these guys are mirrors of those guys, apparently. So I also don't care about that. Okay, I was assuming this was going to say something relevant to me, but because it says thus indices into the palettes are formed as follows, but that doesn't really relate to this at all. So indices into the palette. Huh? I think they're trying to... Whoops. I think they're trying to do some clever math about, like, referencing an address to how it maps to addresses in this sprite table. I don't know. This wiki is... There's so much information, and it's so not great. I need to... Alexander says, if you don't have a quotes list, you should get one. Assembly failed. Sick. Okay, sorry. So how the fuck do these palettes work? Am I just... Are these just the palette colors? Like, So 3F01 to 3F03, are those just my three colors? I guess. So 3F00 is going to be our universal background color. I guess I can write what is going to be there. I guess I can maybe write, here's what I'll try. I'll try writing 0D to 3F00, so our background is black. And then we're going to have to play with it because I don't quite know what the index values and the actual characters are for this text because I didn't make it. So, how about maybe we should just like choose some unique-ish colors so that I can tell which one was which. Let's see. So maybe I can do like a blue, so we can write 11, and then purple, 14, 17, this kind of brownish, or maybe 16, and 19. We'll pick them when we get there. Let's just do that. And then maybe drop this code into... Nah, we can burn it. We can burn it. Because if I change these palette values, then it should show something on screen, hopefully. So yeah, let's go here. Set palette. We're just going to do the background palette. So background palette values. So we're going to load a. So the background was going to be 0D is what that looked like, and we are going to store that to. Oh right, we have to do this thing. No, we do this thing because we're writing to VRAM, which we have to do through this port. So we're going to do the same thing, but our address is going to be 3F00, and we are going... Then we write 0D. Universal background black. And then I guess we'll basically just be copying this code. Several times. One for each color. No, you really can't help me with the SEM files, I promise you. Okay, so for this color, let's do, this is the part where we get to choose some random colors. Let's do 11, and then I have to change my... Wow, no, I really screwed that up. 3F01, we are going to write the color 11, then 3F02, I'm going to write the color, let's go 14, and then 3F03, we are going to write the color 16, orangish. And that's, I only get 3 colors, so that's it. So actually let's set that to like a green. Now that will be a little bit more obvious. And now, let's build that and stick it on the chip because that, firstly it's getting late, I can't stream for that long. And I want to get it on the chip and see if we can see a visible difference. And if we can't, then I'm sorry, this was a terrible, terrible episode. Did I misspell background? Where did I spell background? God damn it, Tom. Are you just screwing with me? I'm gonna ignore that for now. Okay, let's save this. Let's select all. Copy it, throw it into our poor excuse for an assembler, that someone worked very hard on, so don't, you know. Let's not make it seem like I don't respect their work. It's cool that this exists. Okay, download that binary. Yes. Save it. Let us save this off as... yeah, I guess I'll start dating these. 8 for end of day. And we will make a note that that is set palette 0. And of course, you know, the way that this is going to work out is that none of the attribute tables, because again, I still have to set the attribute table values, which I have not done here. So we're just using whatever they are defaulting to, you know, just the random noise in the machine. And just watch, none of them are going to be using palette 0. But there's only one way to find out. So let's open XGPro and load that binary we just made. 8 for end of day, set palette 0. And load it starting at offset 1 for the reasons that you should already know, frankly. And the chips, it's already in there because we were just programming it. Well, we were just reading it to get our code out so that we could put our code back in. So let's clear the check ID bit and program. Go for it. Come on, buddy. And verify, and perfect. So let's jam this in the cartridge and pray that I have something interesting to show you. Note, yes, I could totally run this in an emulator, but because you have to reconstitute your program ROM and your character ROM into a file with the NES headers that the emulator reads to know what mapper you're using and stuff, there's probably a tool to do that, and I don't have time to look it up right now. So we're just gonna grip it and rip it, as I have occasion to say. Okay, let's go to the capture. Let's hope the capture card is still working. Yay! Okay, that did something. Yep. None of them, either I didn't set palette 0 right, or none of them are using palette 0, but something changed. Because that is interesting. Because now that one character is all different. Okay. I wonder if that's because the background color was a gray, and so I've set the background color correctly, but that still none of the attributes are set to use palette 0. So we've made a small change. I think this is my A up in the corner there. Do you see that? So it's there. We can see the A. But okay, I gotta cut it off because I have a couple chores to do, and then I have plans. So I will see those of you that I have plans with shortly. And everybody else, thank you for watching. Yes, Alexander, it is a TL86XX, which everybody calls a Mini Pro. Damn it. So I did misspell background. I will do that later. Yes, chores, I have to feed the chickens. Okay, short episode. We just make a little progress every time. Hopefully next time I'll be able to get a little bit further because I don't have to, you know, reconstitute my assembly from nothingness. So I'm cutting it off. See ya.